name is Wonyoung. I'm currently a PhD student at the Department of Urban Studies and Planning at MIT. I'm going to talk about our paper titled Beyond Fairness, Reparative Algorithms to Address Historical Injustice of Housing Discrimination in the US. We start by introducing one assumption of fairness in machine learning. People represented in the data have been fairly treated throughout history. Because usually what machine learning sees is the data at present. It uses that to predict future. So it is natural to focusing on assessing fairness within the particular moment of time the data capture. So in this case, the assumption means in the loan application, people A, B, and C have been fairly treated throughout the history. We also have questions about how machine learning fairly predict, even if the system achieves perfect accuracy based on all of the fairness notions in which the fact community has been actively developing. Then we revisit this question: is this really true? Absolutely not if we talk about housing discrimination in the US because of the private and state-sanctioned discrimination around housing. It's not a full list of history of housing discrimination in the US, but indeed we list some of them. First and foremost, in transatlantic slavery, enslaved people were considered commodities rather than a person. Even after slavery abolished, many reconstruction programs were not fully realized. Rather, de jure segregation and discrimination caused residential segregation on the basis of race, and state-sanctioned and private discrimination were rampant on the basis of neighborhood. Even after the Fair Housing Act, which prohibit discriminatory housing policies and practices on protected class, such as race and gender, de facto segregation and discrimination in housing rather continued. In the period, spatial pattern of the segregation was not largely changed because the Fair Housing Act did not enforce residential integration. Rather, in the segregated neighborhood, more predatory financial tools around mortgage lending induced more subprime loans to borrowers of color, and such reverse redlining practices caused the foreclosure crisis. All of this story means the starting line is different. For instance, let's see how starting line is different by race in mortgage lending. Here it shows the distribution of the loan-to-value ratio and debt-income ratio by applicant race. These are loan applications for conventional loans, which usually require 20% of down payment. White borrowers tend to meet such down payment requirement, whereas the black borrowers didn't have much down payment. And black borrowers have higher debt-to-income ratio compared to white borrowers. As a result, for instance, Federal Bank of Boston measured the racial wealth gap in 2015. White people's median net worth was $24,500, whereas the median net worth of black people was only $8. All of this is an example of historical bias, so it can occur even if the data is perfectly measured and sampled if the world leads to a model that produces harmful outcomes. So these issues show how training data set can encode past discrimination. So in this paper, we suggest a reparative approach in algorithmic justice to address historical bias. So the reparations mean the full acknowledgement of past harms and figuring out the ways in redressing the past and ongoing harm. It is really important to confront how American history has shaped the economy and political landscape. We specifically focus on reparations and housing related to African Americans for several reasons. First, as we described before, black people have been systemically harmed by unequal housing policy, including redlining and residential segregation. And they're the group for whom reparations have been a public conversation since the end of the Civil War and the abolition of slavery. So we specifically focus on housing reparations cases in municipal scale. For instance, Evanston, Illinois enacted the first government-driven reparations program in municipal scale. So we introduced two case studies for imagining a reparative approach in machine learning in mortgage lending in the US. So case study 1 identified historical bias in mortgage lending, and then case study 2 explores how machine learning can be applied not for risk assessment, but for assessing the reparative potential for policy interventions. The first step of the reparative approach is identifying historical bias. Through this kind of study, government can identify the wealth gap at the neighborhood level and thereby characterizing the historical bias. So we use two data sets. One is residential security maps made by HRC, which I will describe more on the next slide, and matching with historical census data. So they are census tract level census data ranging from 1940 to 2019. And we employ causal inference method, particularly matching and weighting, by constructing spatially as JSON control sets. So HRC maps look like this. And HRC graded mortgage security from A best, B still desirable, C definitely declining, and D hazardous. This one is the map of Boston, but these security maps were all over the US. So we basically combine historical census data with HRC maps to figure out the counterfactual understandings of the neighborhood level racial gaze. Among available data, we are interested in three outcome variables: homeownership rate of the non-white people, and median home value, and return on investment rate. So the treatment variable here is whether or not a neighborhood was assigned as D grade, and this is the result of the average treatment effect on the treated. So first, this shows that after the fair housing was enacted, the home ownership of the non-white people was more concentrated in D-grade neighborhoods. And the median home value was always lower in D-grade neighborhood and keep diverging because of reverse redlining. And basically the gap expanded even more than before the Fair Housing Act was enacted. And the return on investment rate difference converged and even flipped in the 2010s, but the foreclosure crisis rolled back everything. So this study further suggests that without bringing historical context, applying only fairness criteria in algorithmic decision making in mortgage lending in the US is unsatisfactory and unfair. And the second study estimates the financial resources for supporting today's black borrowers, and it basically aims to calculate the cost that is needed for black borrowers who got rejected to get a prime loan to be accepted. And it uses the home mortgage disclosure 2020 data, and it's crucial to use the data of 2020 because it started to include loan to value ratio and debt to income ratio. And for calculating the cost of housing reparations, we relied on previous literature on algorithmic recourse, and particularly the actionable recourse paper. And this framework and method provide ways of actionable recourse if one was negatively categorized from a linear classifier by testing a grid of action sets of features. So first we trained the logistic regression classifier, and the outcome variable is a dummy variable of whether or not the borrower gets a prime loan, and we uses the features listed down here. And we did not include the applicant race, ethnicity, and gender because usually model developers are not allowed to use these kind of variables. And we constructed action sets and we turned on two features: loan to value ratio and debt to income ratio. As you can see, other features are not actionable in the context of housing reparations. Then the last step is calculating the cost of flipping loan decisions for previously rejected black borrowers. For instance, when a black borrower applied for $85,000 loan to buy a property valued at $100,000 with the $15,000 down payment, in this case, the loan to value ratio is 85%. And if the actionable recourse algorithm recommends to decrease the loan to value ratio to 80%, then the estimated cost of assistance and reparations is $5,000. So in 2020, the number of black borrowers who were denied prime loans were 41,830. Among them, 39,028 people could flip the decision. So the total cost of the down payment assistance would be $891 million, or on average $41,256 per person on average. And the total cost of debt relief assistance would be $3.6 million per month, or the $205 per month per person on average. Here it shows the total and average compensation for changing the loan value ratio by state. And this shows the same state level but for changing debt to income ratio. FHA loans usually requires only 3.5% of down payment. So compared to the conventional loans, the action or recourse algorithm couldn't identify ways of flipping decisions by decreasing loan value ratio. So the total cost of debt relief assistance would be $26 million per month, or $578 per month per person on average. So this shows the same state level for but changing debt to income ratio of FHA loans. So this result could be used to examine local housing reparation programs, for instance, Evanston, Illinois program. So in Cook County, where Evanston is located, a black borrower who applied for a conventional loan but could not get a prime loan needed to get $33,289 down payment assistance and 173 monthly support for paying the debt to flip the decision. Or ultimately, if the borrower applied for an FHA-backed loan, then they needed to get a 591 monthly support on average for the debt payment. And using this $25,000 for the Evanston, only 27% could flip the decision when there or in the conventional loans. Or when they're in the FHA loans, 66% of the people could flip the decision if they spend $25,000 for 2 years paying their debt in this case. So we really hope that this work bridges between the local housing-based reparation programs and algorithm accountability by developing ways to measure the cost of housing-based reparations. So ultimately, this will contribute to how to operationalize, because many loan decisions rely on the automated decision making through platforms and algorithms. So we wanted to say that only when we act beyond fairness and devise an algorithmic process grounded in historical context, then can we achieve substantial improvement and converge differences that occur because of the historical and structural discrimination. And thank you very much.